Okay, so we're doing 2.5 special integration. This is going to be similar to the first question, or we're going to do the same steps as the first question. So, this question is from the homework 2.5, question 1. And so you can see here, I've already identified what is m and what is x, what is m and what is n. So this is m and this is n. So we already found what it belongs to. But to see if it's exact or not, we would find the partial with respect to the opposite variable. So this is respect to this function is going to be respect to y, and this one is going to be respect to x. You could see here. See? So since this m function is from dx, we're going to do the opposite variable. So it's going to do respect to dy now. And this one is respect to y. We're going to find respect to x now in these functions. So let's find the partial derivatives. So the partial of y, or respect to y, is given here 2xy, right? As you can see here, since we're finding the partial derivative, this is a constant. 2 is a constant and x is a constant. So what we do, right, is we would take that out and find the partial. Of this y, which is just 1, right? So we substitute the 2x back in, so 2x times 1 equals 2x. So my equals 2x. We do the same steps when finding the partial of n, the function n respect to x now, right? This is a shortcut for saying partial. So we have y squared minus 3x squared, right? Again, we look at the first one, and this is not, there's no x, right? So this is a constant, and any constant derivative to a constant is just 0, right? And right here, negative 3x squared, and that's respect to x, so we just treat it as a derivative. So that rule would be 6x, right? So that would just equals 6x. 6x. As you can see here, this and that does not equal each other, right? Does not equals negative 6x. So basically, since not equal each other, we would find the special integration. And special integration is defined as mu of x or mu of y. So given the formula, this is mu of x equals to this minus, sorry, that's not how it is. It's e to the integral of my minus nx all over the function of x, right? The n function. And mu y is equals to e to the integral of the opposite way now, so n of x minus my all over m, right? So let's find each of this. Let's do x first, and hopefully that is the special integration. So the point of the special integration is to find which variable depends, like only one variable depends on another, right? So let's do this first. So we have what mu y is, right? 2x. So e integral of 2x minus negative 6x, right? All over the n function, which is y squared minus 3x squared, right? Y squared minus 3x squared dx, right? And what we're supposed to do here is basically trying to factor it out and try to simplify it more. So it depends on one variable. So let's simplify this inner one first. Let me just do this. So we have 2x minus negative 6x. So that would just be 2x plus 6x, which is 8x. All over y squared minus 3x squared. As you can see here, you can't really do anything to have separate this and that, because I don't think it's not possible to have depend on one variable. This depends on two variables. So let's go to mu of y. So this goes here. So we have e to the integral of n of x, so that is negative 6x minus 8x, minus 2x, right? All over m now. So we say m is 2xy. 2xy. It's dy. And let's do the same thing here. Let's try to simplify this so it's only to one variable. Depends on one variable. So that just equals to negative 8x, right? All over 2xy, right? Since we could basically simplify this even more, right? This would just be, you could look at it as this way, of y of 2x, right? That cancels each other out, kinda, and we're just left with negative 4 all over y. And that is with our inner part, but we still have to figure out the integral part. So we have e to negative 4y dy. And we could basically say that this is a constant, right? This goes to other outside the integral, so this is 4 to the negative 4 to the integral of 1 over y dy, right? And that is a elementary integral, and that just equals to natural log. So, and we have a constant, so negative 4 natural log of y, right? And we have an exponent to that, so we have e. I made a mistake on the other video. In the other half portion I was recording, I replaced this with x, but it should be y. So since we got that out the way, let's use this mu of y and multiply it by our differential equation, right? So let's multiply it by y to negative 4th, since I find that easier to do with the fraction. So so this would be 2xy to the negative 3rd dx plus y to the negative 2 minus 3x squared to the y to the negative 4th, right? So let's find what the partial of the function m respect to y, right? That'll just be equals to, this is a constant, so we bring that there, -3 and -1 here. So we have -3 times 2x y, 3 minus 1, well, that just equals to -6 x y to -4th, right? Now let's do this one right here, which is the partial of n respect to x. So we're given y to -2, which this is a constant, so that equals to 0 since we're doing respect to x. And this is a constant, so this just goes out the way. And we're focusing on this, so -3x squared. So that would just, the derivative of that would just be 2 times -3x, right? And that'll be just x, yeah, times y to -4th. Well, that just equals to -6x, right? Y to -4th, right? And as you can see here, this is exact, right? So exact. Now we could solve this differential equation. Since this is exact, we get this function. And let's do this. Our what we do is get our of this, and that just equals 2 x dx, and this will be part of like we're doing now, since that just equals to 2x y to -3rd dx. As you can see here, this would just equals 2 y to -3rd 2x dx, right? And that would just equals 2, the integral of 2x dx, that would just be this, 2x, and it would be 1 plus 1 over 1 plus 1, that just equals 2x squared over 2, which equals to x squared. So now we have our integral is x squared times y to -3 plus this. And what we're going to do is find what h of y is to complete what our f of x function is, right? Which equals to x squared times y to -3rd plus h of y. And just 2 plus c sub naught, right? Because it's integral, so we need a constant. So after that, to find what h of y is, we would take the partial respect to y, right? So doing that, we could eyeball that. We could say respect to y is x squared is a constant, so that goes out, and we find that, so without this derivative, right? So what's the derivative of y to -3? So that would just be -3 y to -4, and this would just be h of y, h prime of y, right? And the rule is that, sorry, I didn't mention it earlier, f y equals to the function, the n of x, y. So let's see if it cancels stuff out, right? since this is this right here, sorry, right? Oh, I'm sorry, this one. Now we make it equals to n of x, right? So this is our right here. So as you can see here, that these and this is the same thing, and since this is on the opposite side of the equation, we could cancel these out, right? So we're left with h prime of y is equals to y to the -2, right? And since we need to solve for h of y, we also obviously need to find the integral of each side. So what we do, the integral of h prime y is just hy, right? Now equals to the integral of y -2 dy. And now this equals to, let's do it right here, y to -2 plus 1 over -2 plus 1. That just equals. Okay, continuing on to our video, I got disrupted by a call. We would now, since we have h of y, we could plug it back into our function, right? Let's see. I forgot the c. It's 1. So what we do here is equals 0, and we would minus c sub 0 minus c sub 0, right? That would just be another constant, right? And let's also plug in what h is also. And h of y would equals to negative y to the negative first power, right? Dang, it's not working. So negative y to negative first power plus c sub 1 equals c, right? Since we negative c sub 0 is just another constant. And then we minus c sub 1 minus c sub 1. And now we finally have what f of x is, right? Is equals to x squared times y to the -3rd minus y to the first power equals to c, right? You could further simplify that, right? But this is how I would answer the question.